turn on the record, new page, draw. All right. Multiplying complex numbers is just exactly like multiplying a polynomial. In other words, you're going to FOIL it. It's only going to be one difference after you do it. What do you get when you FOIL that?
You get 8. And then you get 12i.
Minus 12i.
Minus 12i.
Because it's 4 times minus 3i.
And then you get minus 4i. And then plus 6.
6i squared. In other words, when you multiply minus 2i times minus 3i, you have to multiply the numbers together and you have to multiply the i's together. Okay? Now, here's the thing. I squared is a real number. It's equal to minus 1. So whenever you're doing these problems, you want to convert all your I squareds to minus 1. So this is going to become 8. I'm going to combine those two terms, minus 16i plus 6 times minus 1. Well, that's 8 minus 6, 2 minus 16i. There's your answer. So whenever you have powers of I, you always want to convert it. You leave I as I, but anytime you come across an I squared, you change it to minus 1. Anytime you come across an I cubed, you change it to minus I. And anytime you come across an I to the 4th, you change it to 1. Because I to the 4th is I squared times I squared. Okay?
Okay.
All right. Did we do C? Did we just do 8A last time?
We did 8A and 8C.
Okay. So we've been through how to do C.
Yes.
That's not a division problem. It's a multiplication problem. In other words, we're going to multiply the bottom by the conjugate, and we're going to multiply the top by that same conjugate of the bottom.
Right.
Okay. What next?
8D.
We just did 8B, I think. Yeah.
D.
I'm sorry. C?
D.
Oh.
We did B.
Yeah. I didn't see an 8D. I kept looking for it. I thought that was the next one. Okay. Plot, label, and find the absolute value. Okay, the horizontal axis is the real axis when you're, and this is the imaginary part here. Okay, so it's not an XY grid. To plot that point, the real is minus 3. So I would go to minus 3. And B is 6, and B is the imaginary. It's up to 6. So that point right there is minus 3, comma 6i, I guess, is the way you'd label it. That's definitely the point. Now, what's the absolute value of it? It is the square root of the two numbers squared. In other words, absolute value, at least I'm pretty sure, is this. I don't mean the absolute value, I meant that. The absolute value equals the square root of the two numbers a squared plus b squared. Well, that's 9. That's 36. So it's the square root of 45. What does that simplify to?
3 to the 5th power. Oh, 3 and
3 root 5.
3 root 5, yeah.
Because it's really square root of 9 times square root of 5, and then the square root of 9 becomes a 3. So, do you have answers for this? For these?
Like an absolute answer?
Yeah. In other words, do you know what the answers are on these?
No.
Okay. Because I'm 95% sure about the absolute value. And you know what? I'm 99% sure. Okay. So I need to go to the next page. Is that right?
That's the last page for part 1, I think.
Oh, so I got to go to the other document then. Okay.
Yeah, part 2.
This document here. This right?
Yes.
Okay. Aha. So you're dealing with parabolas as conic sections. In other words, every parabola up until now that we've talked about has looked something like that, right?
Right.
Well, when you talk about parabolas as a conic section, there's two additional things. There's a focus, always inside, approximately there, and there is a directrix. And the relationship between the two is this distance is P, and this distance is P. In other words, the distance from the focus to the vertex is the same as the distance from the vertex to the directrix. And the directrix is, again, an equation of a line. Okay? Now, they also give you a different general format. Let's talk about that for a second. I'm always a little upset that they do this, but if I go back and look at vertex format, all right, well, because they're talking about parabolas as conic sections, they have a different format for that. First of all, A is equal to 1 over 4P. Okay?
Okay.
And P is the distance to the focus from the vertex. But what this now becomes is if I move the K to the other side, Y minus K, then I'm equaling 1 over 4P times X minus H quantity squared. Now I'm going to multiply 4P by everything, and this becomes the standard format for a parabola, a conic section parabola. And you see everything I did to get from there to there.
Yes.
Why they do it, I'm not quite sure, and not every school does it. Some schools give you the vertex format and they tell you A is equal to 1 over 4P and that's it. And they let you deal with it that way. Problem is that all of the problems you see, they're kind of in this format down here. In other words, that very first problem you see, y equals 12x squared, hold on a second. What does this mean? X squared equals 4cy. They're just giving you the standard format of it?
Yes, I think so.
Okay. So it looks to me like they want you to take this y equal 12x squared and convert it to that format. Right?
All right.
Well, first of all, in this problem, K and H are 0. So the format for this particular problem is 4p times y equals x squared. Now, what are we looking at? We're looking at y equal 12x squared. Well, I need to figure out what p is. So let's divide both sides by 12. So we have 1/12 y equal x squared. Now, we have matching formats. Okay?
Okay.
And I can then say that, okay, if 1/12 is my coefficient of my y term, then 4p has to equal 1/12. 4p equals 1/12, p equals 1/48. And now I can graph it. Let's go scroll down and do just that. Sketch a graph of it. Well, I know the origin, the vertex is right there. So it's got a vertical stretch factor of 12, so it's pretty skinny. And p is at 1/48. If I did my math right, that seems like a strange p, but we can go back and check it. And then the directrix is always perpendicular to the line or the axis of symmetry, and the equation of this line would be y equal minus 1/48. Let's see if our p came out right. In other words, if I go back and don't use their format, but use this format, I get y equal 12x squared, right? Well, we know that a is 12 from that. So if a equals 1/4p, and I know a is 12, yeah, if I do the math, multiply by p and divide by 12, I get p equal 1/48. So I did it correctly. And you can honestly use either method. You can use either the vertex format that you're used to, and remember that a equals 1/4p, which means p equals 1/4a. That's really what I should be writing, is p equals 1/4a, because if they give it to you basically in vertex format, this is the easiest way to do it, is to just know that p equals 1/4a, and they're giving you an a of 12, so p equals 1/48. What's the axis of symmetry?
Wouldn't that be 0?
X equals 0. Remember that the axis of symmetry and the directrix are both equations of a line. You can't just say 0. You'd lose points for that. You have to say x equals 0. A vertical line that is the y-axis is defined as x equals 0.
All right.
All right. Well, that's a dicey thing they told you right there. I guess that allows you to figure out that p is 1/4a. Okay, graph on your Inspire, sketch a graph, then determine the x-intercepts, y-intercepts, minimum, maximum, and what the value of all these are. Well, we don't really need to sketch it other than to verify it. Do you know how to sketch these on your Inspire, don't you?
Yes.
Okay. So let's talk about X and Y-intercepts. The very first thing it wants are the X and Y-intercepts. Hold on. What's the Y-intercept?
Want the y-intercept to be 5?
Minus 5. In other words, the y-intercept is always where x equals 0. And it's the easier thing to find by a lot because it's always this constant. Okay? But notice that if I plug in 0 for x, that term disappears, that middle term disappears, and the only thing I'm left with is minus 5. So the y-intercept is always pretty easy to find. If you've got the thing in standard format, it's easy to find. Now, the x-intercepts, how do I get those?
Once you plug in 0 for y.
Yeah, so 0 equals minus 2x squared minus 10x minus 5. And now to solve that for x, I got to factor it. Well, it's not real easy factoring a quadratic that has a negative coefficient in front of the x squared. That's just a difficult thing to do. So let's factor out a negative 1 and then divide both sides by negative 1. That's going to give us 0 equal 2x squared plus 10x plus 5. What's wrong with that? Nothing. That, incidentally, does not make the y-intercept plus 5. It looks like it could, but it doesn't. This is not equal to y. This is equal to 0. Okay. Now, can you factor that?
Yes.
So what? We know that much. We know this much.
Wouldn't it be 5 and 2?
Well, it has to be 5 and 1. In other words, these numbers have to be factors of 5. But notice that that does not produce the correct middle term. It gives you a middle term of 11x. I switch and put the 5 here and the 1 over there, I'm going to have a middle term of 7x. So I can't factor that. Why would they give you one that you can't factor? All right. Well, we've got to use the quadratic formula. If you can't factor something, you got to use the quadratic formula. What's x going to be equal to? And it's okay to use these numbers instead of all of the negative ones. In other words, A is positive 2, B is positive 10, and C is positive 5 when we plug it into the quadratic. We don't have to use negative 2, negative 10, and negative 5. So plug it in. What's the quadratic?
The quadratic formula?
Yeah, minus B. What's the rest of it?
Minus B plus or minus the square root of B squared minus 4AC all over 2A.
Good. Is that from your memory, or was that on a piece of paper in front of you?
It's on a piece of paper in front of me for now. Hopefully it's
Okay.
in my memory.
Okay. Yeah, you want to practice retrieving that from your memory, okay? Because if you always do these by looking on a piece of paper, you go to take the test, and then what are you going to do? So let's plug in now. What is that going to be?
B would be 10, right?
Uh-huh. So
10.
minus 10.
Then it'd be 100 minus 4AC.
Minus 4 times 2 times 5, all divided by 4. Okay, what's that? That is 40. So inside in other words, the discriminant ends up being 60. So let's write that. Square root of 60 all over 4. Can I simplify square root of 60?
No.
Well, it's divisible by at least 4, which means I can. If I can find a factor of 60 that's a perfect square number, then I can simplify it. Notice how. It becomes minus 10 plus or minus square root of 4 times square root of 15, which becomes a 2 all over 4. Now I can divide top and bottom by 2, giving me minus 5 plus or minus root 15 all over 2. Now I know my x-intercepts. What are they?
Minus 5.
What's that?
I'm just doing it on my own.
In other words, how do we fill in these blanks here? They want 2 x-intercepts. What's the first one?
I'm solving it on my calculator. Do they want absolute answers? Or?
Well, the first one is minus 5 plus root 15 divided by 2. And the second one is minus 5 minus root 15 divided by 2. In other words, to come up with both answers, apply the plus for one of them and apply the minus for the other one. So in other words, what I would put right there would be minus 5 plus root 15 all divided by 2. And what I would put right here is minus 5 minus root 15 all divided by 2.
All right, so the first one, it comes out as root 15 minus 5 over 2, but that can't be right.
I'm sorry, what?
The first one comes out as root 15 minus 5 over 2, but could that be right?
Yeah. That's the first one. Right. Root 15. Almost prefer to leave it like this. Only because, in other words, instead of switching those two terms, I can see why you did it. It makes it, you would think you should do it. And maybe you should. I don't know. I prefer to leave the answer like this because this is the way all your answers for the quadratic formula end up looking. In other words, you always have a whole number there and you have an irrational number there. So I tend to not switch these. In other words, my first answer would be minus 5 plus root 15 all over 2. And then my second answer would be minus 5 minus root 15 all over 2.
Okay.
And you could switch the first one. It's not going to make much difference, but there's really no reason to do it. Now, circle one or the other, minimum or maximum. What are we going to have in this picture? What kind of parabola do we have? Is it one that opens up or one that opens down?
Wouldn't be one that opens down.
So do we have a minimum or a maximum?
We have a maximum.
Right. So you'd circle the max, and they want to know what the value is. Well, here's what we're looking at. Some sort of a parabola that opens down. Let's see, it goes through this point, minus 5. So it probably does something like this. And we need that value, the y value of that. We know where it occurs. Actually, we don't. We never did figure out the vertex on this thing or the line of symmetry. But, well, I guess for us to figure out this y value, we need to find the vertex. Okay?
Okay.
So the easiest way to find the vertex is to find the x-coordinate of it and then plug in that value into this function, and that'll tell you what this point is. Okay?
Okay.
So what's the formula when you have something in standard format for the x-coordinate? Remember, it's the first half of the quadratic. What is it?
The first half of the quadratic formula?
Yeah, that's a good way to memorize it. Minus b over 2a. Do you see why I call that the first half?
Yes.
Not quite the first half, but if you were to separate the quadratic into two fractions, that would be the fraction on the left. So let's do that. And here it doesn't matter if we use these numbers or the positive ones. We probably want to use these at this point, especially for determining what y is going to be once we figure the x-coordinate of the vertex. So what's minus b over 2a?
It'd be minus, well, it'd be plus 10 over 2, negative 2, minus 2.
Let's see, it would be plus 10 over minus 4. Because a is minus 2, 2a is minus 4. Okay? So what that means is I drew this quadratic wrong. It's still going to go through that y-intercept, but it's going to do it from that side. In other words, that gives me the x-coordinate. That x-coordinate right there is minus 5/2. And that's also the axis of symmetry would be x equals minus 5/2. Now, the point we want to know is that point right there. Well, if I plug in minus 5/2 for x, I will figure out what y is. So y equals, and again, I always recommend doing this very, very deliberately like I'm doing now, because it is so easy to make a mistake when you have all of these minus signs. Hold on. Already made a mistake. Minus 10 times minus 5 over 2 minus 5. So we just have to evaluate what that is. Well, again, let's do step by step. How do I evaluate this expression? Get rid of your exponents first. What's minus 5/2 squared?
Minus 5/2 squared?
Which is what we have to do. In other words, we have to square minus 5/2. What's minus 5/2 times minus 5/2?
Minus 25/4.
It's actually positive.
All right, because it's too negative.
Because it's a negative times a negative. Okay?
Yeah.
And let's do this part. That is 50 over 2. So that's going to turn into a 25. Is it plus or minus?
Wouldn't it be a plus?
And then minus 5. Okay. So this becomes let's see, I can take that 2 and make that a 2. So here's what I have. Let me scroll down, get a little more writing room. I have y, when x is equal to minus 5 halves, I have y is equal to minus 25 halves plus 25 minus 5, which is plus 20. Now, to combine those two numbers, I find a common denominator of 2. 20 is equal to 40 over 2. Now I can operate on the numerator, and I get 15 halves. That's the value. That's what you want to write into there, and it's a maximum. In other words, that is right there 15 halves on the y-axis.
Okay.
Okay? And I think that's all they ask for there. Whether the following quadratic has a minimum or maximum and what that value is. Yeah, so we answered everything. All right, let's look at 3.
Yep.
Suppose a water balloon is dropped from a height of 27 feet. How long does it take the balloon to hit the ground? Use the equation when the object is dropped. All right. What this equation says is the height of the balloon at any point in time is minus 16t squared, and that comes from the acceleration due to gravity. In other words, whenever you drop anything above the Earth's planet, it is going to accelerate. It doesn't just fall at a constant velocity. It accelerates as it falls. And this is what it accelerates by, is minus 16t squared plus whatever height it was dropped from. In other words, when t is 0, the height is going to be the height that was dropped from, h sub 0. That's what h sub 0 means. So in our problem, we've got h equal minus 16t squared plus 27. Okay?
Okay.
So this will tell you the height of the balloon at any point in time. In other words, when t is 0, the height of the balloon is 27. At 1 second, the height of the balloon is minus 16 plus 27, or 11. At 2 seconds, it's going to already be hitting the ground. Okay? So how long does it take for the balloon to hit the ground? Well, what's its height when it hits the ground?
0.
That's what I'm going to plug in for that h. And then I'm going to merely solve this quadratic. Okay? And that's actually a fairly easy quadratic to solve. If I move the 27 to the other side and divide both sides by minus 16, I get this. Right?
Right.
That now becomes pluses. Now what?
You square root.
Okay. So t, the time that it takes to hit the ground, is going to be the square root of 27 divided by 16, with square root of 16, which is 4. And square root of 27 is 3 times 9, so it can be written as 3 root 3 divided by 4. That's when it hits the ground. Now, you'll notice that I violated something I've always told you to do. I've always said that whenever you're taking the square root of both sides of an equation to solve it, always begin your answer with plus or minus. And that's a true statement. It is plus or minus. Okay? The problem is there's no such thing as a minus time. But think of the appearance of this gravity, or of this, this is a different, this is not the one we just drew. Hold on, let me Just a second, I want to draw this so that you'll understand why we get a positive and a negative time. The balloon is dropped from 27 feet, so drop straight down like that. But if I graph that equation that we have, it becomes this. Okay, well, this is the time axis. So this point right there is the positive answer. This point right there is the negative answer. But that's why you have two intercepts. But you throw the negative answer out because time cannot be negative. It's right. Like dimensions. If you have a rectangle or a garden and you come up with a negative dimension, you throw it out because you can't have negative dimensions. So right. That's why you end up with two answers, one of which is almost always thrown out, where all of this is thrown out.
Okay.
All right. I guess that's fully answered. Let's look at number 4. Write a quadratic in any form from the given information. Okay. Goes through the point -1, 1, and it gives us the vertex. Which form should we use?
Vertex form.
What's the vertex form? Give me the general.
Isn't it y equals x, no, a, then God, I can't believe it. Oh, it's a x minus h squared plus the k, plus k.
Right. And you know how I've always said that it's always minus. Well, it's always minus with the y also. If I move this k to the other side, it's y minus k. The only reason it's a plus k is because I moved it to the right side of the equation. So if you're trying to remember these formats, anytime you run into an x and an h or an x and a p or a q, it's always x minus those numbers. Okay. Until you get to calculus. It's not until you get to calculus where you run into an x plus h. Now, they gave us the vertex, -2, 4. So how much of this equation can I write now? Don't know what a is yet, but I know what h is. So what goes in the parentheses?
Wouldn't it be 2x?
X plus 2. In other words, it's x minus a -2, which ends up being x plus 2 squared. K is 4 plus 4. So we know that much. We still haven't answered their question yet, though. We still have not written the quadratic function. We need to solve for a. Well, we know it goes through that point. So how can I solve for a?
You can plug it in.
Plug those coordinates in for y and x. So what's the next line?
Wouldn't it be y equals a?
Hold on. Do this one step at a time, very methodically. I listed the general, and then I listed everything I knew, which was h and k. Now I'm going to plug in this point for x and y. So y has to be 1. Still solving for a. X is -1. This is what I mean by being very methodical. Don't do multiple steps at once. Now, -1 plus 2 is 1. 1 squared is 1. A equals -3. Now I have my function. In other words, y equals minus 3 times x minus x plus 2 squared plus 4. In other words, whenever they want you to write a function, your final function needs to have both the y and the x in it, but everything else needs to have been solved for. In other words, you always figure out what a is, you figure out what h is, and you figure out what k is, and you fill those in so that your final function is back to y equals a function of x.
All right.
Okay. And the second one gives you the X intercepts, and it goes through that same, well, not the same point, a different point, 1 comma minus 1. So on this one, we should use the X Intercept format. What's the X Intercept format?
I don't know that one off the top of my head.
Well, it's actually the easier one to memorize. And they use P and Q here. P and Q being the X-intercepts. Okay, well, they gave them to us. So how much of this equation can I write?
You can write y equals a x plus 3. And then that's times x minus 7.
And again, it goes through this point, a different point, but similarly looking. So again, I need to solve for a. So what's the next line?
Wouldn't you have to plug in your number, so it'd be 1
Minus 1.
minus 1 equals,
That's the y coordinate. Okay.
equals, all right, equals a 1 plus 3.
All right.
And then that's times 1 minus 7.
Okay, so I got minus 1 equals 4a times minus 6. Now I got minus 1 equals minus 24a. So I got a equals positive 1 divided by 24. What's my final equation?
Maybe y equals 1 over 24. That would be times x plus 3. And then that would be times x minus 7.
Yeah, you basically take that and just replace a with what we solved for. Okay, so you want to use the format of the, in other words, if we took the vertex they gave us here and we tried to put that in standard format, that'd be a much harder problem. But putting it in vertex format's pretty easy. Same thing with this. If we tried to put that in vertex format, it would be problematic. It'd be a harder problem. Wouldn't be impossible, but it'd be a harder problem. But there's 3 formats. There's vertex format, there's X Intercept format, and there's standard format. Those are the 3 formats you need to be familiar with and be able to switch back and forth between the 3. And that's a bit of a trick. I didn't see, oh, we got more problems here, don't we? I thought we were done. Okay, so let's look at 5. Again, you'll notice that this is kind of similar to the last one. This means the height as a function of time is equal. There's that minus 16 again, and you're always going to see that. But now we've got a minus 2. That means it's moved 2 units to the right, right?
Right.
In other words, that's a horizontal shift. I'm not sure we need to know that, but let's see. Sketch a graph of the function from 0 to 10. Well, and label the vertex X and Y-intercepts. Well, notice it's in vertex format. So what's the vertex?
And the vertex be
That's A. That's H. Okay.
all right. So vertex would be t minus.
No. Remember, it's X minus H. Or, in this case, T. In other words, the T here would normally be X. But when you're dealing with projectile motion or things falling, it's always T. Everything's always a function of time. But doesn't change what H and K are. H is 2, K is 264. So there's the vertex.
All right.
Okay. That's the X and the Y coordinate of the vertex. Now, label the vertex and X and Y intercepts. Well, let's see if we can do a approximate graph on this thing. We'll call this point right here 2, 264. And we know it opens down. It's got a pretty high stretch factor, 16, so it's going to be pretty skinny. Something like that. What's the y-intercept?
Isn't the y-intercept 264?
Not in this case. Because remember what the y-intercept is. The y-intercept is where t equals 0. In other words, it's h of 0. So if you plug in 0 for t, what do you get? You don't get 264. If it was in standard format, then it's set constant because both of the other terms disappear. But when it's in vertex format, you have to plug in 0 for t and see what you get. Well, minus 2 squared is 4. 4 times negative 16 is minus 64. Plus 264 is 200. So this point right there is at 200. That's the y-intercept. Well, it's actually 0, 200. Now, figuring the x-intercepts, which we need and they ask for, label the x and y-intercepts. How do I get the x-intercepts?
Wouldn't you just put y equals 0 or t equals 0?
There's no y in this. What is going to be equal to 0?
H.
H of t. And that's now equal to minus 16 t minus 2 squared plus 264. Well, let's take that 264 and move it to the left. It means minus 264. Now we have to solve for t. Well, what's the first step in solving for t?
Wouldn't you do t minus, you'd distribute the 16.
No, can't distribute the 16 because t minus 2 is being squared. The 16 is not.
I said square it.
Well, I'm going to divide both sides by minus 16.
All right.
That gets rid of it, which is what we want to do. Okay? And also turns this positive. Now I'm betting that 16 goes into that an even number of times. I'm going to use my calculator. 264 divided by 16 equals 16 and a half. I was wrong. So 16 and a half equals t minus 2 squared. Now, 16 and a half. 33 halves. Wow. And I'm doing it this way because sometimes it's easier to take the square root if it's an improper fraction. Now, whether it's an improper fraction or not, it's easier to take the square root. It's hard to take the square root of 16 and a half, right?
Right.
But you can take the square root of 33 halves by, that's square root of 33 over square root of 2. That equals t minus 2. And again, it's plus or minus, but we don't care about the minus part. So we're going to leave it off. I still have to solve for t, which means I have to add 2 to that. So there's my answer. Excuse me. It is plus or minus. Because they asked for us to sketch the graph and label the X and Y-intercepts. Well, when I sketch the graph, I do get both intercepts, and if they want us to label them, that's where they are. One of them's there, the other one's there. Obviously, the one on the right is the plus, the one on the left is the minus. Okay? Now, the last thing you got to be a little careful about is that's not really in proper format there. I got an irrational denominator. How can I change that?
Would you rationalize it?
Yeah, by doing what?
You times it by, would it be 1 minus square?
Remember, I can only multiply this fraction by the number 1. And I want to multiply the bottom by root 2, so I have to multiply the top by root 2. Now I've got 2 plus or minus root 66 divided by 2. Now, can root 66 be divided by a perfect square number? No, it cannot. It's not divisible by 4 or 9 or 16 or 25. So it's simplified, and there's your 2 X intercepts. 2 plus root 66 divided by 2, and 2 minus root 66 divided by 2. So that's what you would put for your X intercepts. Now, find it a little bit interesting that they gave you this graph without any negative. In other words, I presume that's the y-axis and that's the x-axis. And, oh, I see. They want you to sketch it from 0 to 10 only. Okay? Well, this number is negative.
So we describe that?
That's not going to be in the 0 to 10 range. In other words, that's a negative number. This number is in 0 to 10 range. And how do I approximate this? Well, square root of 66 is almost 8. 8 divided by 2 is 4. So this number is about 6. This number is about negative 2. So the only one you're going to graph, the only x-intercept you're going to graph is that one there.
All right.
You're going to start with your vertex wherever that fell, and draw as much of the parabola that fits on the curve. What was the initial height that the ball was thrown? Hold on. A ball thrown into the air from the top of a building is given by the function. Well, I assume they meant that it's dropped from the top of the building as opposed to thrown up. No. It is thrown up. From what initial height was the ball thrown?
Wouldn't it be the y-intercept?
Yeah. In other words, the ball is thrown at time 0, right?
Right.
We figured that to be 200. So the ball was thrown from a height of 200, and it was thrown up, such that its peak was 264. In other words, it went from 200 feet up in the air to a height of 264 feet, and then turned around and started falling down. And we know 264 is its ultimate height because that's the y coordinate for the vertex. So
right.
That's the highest it got. And it actually got that when t is 2. Okay, what's the maximum height the ball reaches? That's the
264.
Y coordinate of the vertex. When does the ball strike the ground?
Wouldn't it be at the X intercept? Oh, the positive X intercept?
Yeah, it strikes the ground. It strikes the ground when the height is 0, right?
Right.
Okay, so I'm going to do that. You're right. It's the X intercept. It's this, because that's the way we got the X intercepts, was to make the height 0. And that came out to be 2 plus root 66 over 2. So that is when the ball strikes the ground, is at a little after 4 seconds. Based on your graph, what values of t have meaning?
What is it? It'd be anything between 0 and 10.
Actually, it would be anything from 0 to this number. Right? In other words, after it strikes the ground, it doesn't keep going. It's
right.
So any time, let's call this, let's round this off and call it, let's say I said that was 4, that's 6 and change, okay?
Okay.
6 and a little bit of seconds, a little bit after 6 seconds, it hits the ground. So my effective domain is 0 to this number. There's no point in talking about what happens at 7 seconds. It's still lying on the ground. In other words, it doesn't continue to go down. Even though if I draw a graph, the graph's going to look like this. First of all, I throw it from a height of 200 feet. It goes up and then strikes the ground. So that's 264. That is at 6 plus seconds. And if I were to draw the equation all the way, it would look like this. But all of this part here is negative time, so I don't really want to draw that. And all of this part here is below the ground, which it doesn't go. So the only effective domain is that part right there, which is time greater than 0 and less than that number. It was a little bit more than 6.
Right.
All right. That's probably a good place to stop for this session.
Right.
We can pick up with number 6 next time we meet.
Sounds good.
Okay. All right, Patrick. Talk to you later.
All right. Have a good night.
You too. Bye-bye.